Hello students, this video will help you to understand image formation in case of convex lenses. Now just like we have studied about image formation in case of mirrors, the rules for image formation remains the same here also. Except one thing which you have to remember, if the image is formed on the other side of the lens, that means object is kept here, and if the image is formed this side, so that is called real and inverted image. Now also what you can do, you can keep the object this side, image will form that side, so that will be real and inverted. But if the object is kept on the same side and image is also formed on the same side, then it is a virtual and erect image. That means if you keep the object this side, image is also this side, it will be a virtual and erect image. Now all total we shall be dealing with 6 positions of object. Okay, so let's start with the first one. First case is object is kept at infinity. That means your object is kept at infinity. So what you can do, two rays of light that are coming directly from infinity. You can mention object is at infinity. So the rays of light are approaching from infinity. So here you are directly using rule 1 for convex lenses. So a ray of light which is parallel to the principal axis, after striking the lens, it will go through the focus. So see, they will meet at focus. So your position of image is at f2. Write it as at f2 because f2 is on the other side of the lens. Now nature of the image, since it is formed on the other side, you can directly mention real and inverted image. This is real and inverted. And size of the image, you see, it's a point size imaged. So you can write point sized, or along with it highly diminished. Any one of them you can write. Point size or highly diminished. Okay, so this is your first image formation when the object is kept at infinity. With the help of a scale only, draw down your figures. Put the rays also properly. See, don't forget the rays. You have to give the reflected rays properly. So now your second position of the object. Now the object is kept beyond twice f1. As I told you before also, don't take the object too big, don't take it too small, keep it normalized. Okay, so suppose your object is kept here beyond twice f1. Let's use rule 1 first. A ray is parallel to principal axis, thus it passes through the focus. So this is rule 1. Okay, this is rule 1. Next you can go for rule 3. Allow it to go through the optical center, so it will cross somewhere, because rule 3 says any ray of light passing through the optical center will go through it undeviated. So see, this is where the two lines will intersect. Okay, so position of image, you have to write between f2 and twice f2. Image will be formed between f2 and twice f2. Now nature as we mention here, nature of the image will be real and inverted only. It is going to be real and inverted because it is on the other side. So do not get confused. Real and inverted. Now size of the image, if you just measure the size, you will find the object to be a bit bigger. So this is a diminished image which is formed, small sized image. Use a scale so that to get the proper height of the image. Fine. So this is your second image formation. We have used rule 1 and rule 3. Okay. Now coming down to the third image formation, we are taking the object at twice f1. Okay, we are taking the object at twice f1. So let me keep this as f1. This side is f2. So while you keep it on f1, object is kept at twice f1. Let's use rule 1 first. Ray of light parallel goes through focus. So this is rule 1 again. Fine. Then use rule 3. Use a scale, allow it to go through it. So both the rays should actually meet at twice f2. Both the rays should meet at twice f2 after using rule 3. See, it's almost like the center of curvature for mirror. Only difference, other side of the lens. Okay. So if the object is kept at twice f1, image will form at twice f2. And nature, as I told you, this side it will come down. So once again, real and inverted image. And size will be same size. Same size as the object. Object and image will be of same size. Okay. So this is your third image formation. Now coming down to your fourth position of the object. So now the object is placed between f1 and twice f1. Between f1 and twice f1. So somewhere here. So if you use the rules, let's start with rule 1 itself. Parallel to principal axis, it goes away. So this is rule 1. Go for rule 3. So going through optical center, it will meet somewhere here. So see the image formed. Image is formed beyond twice f2. Beyond twice f2. Nature will be real and inverted only. And if you check out the size, it is a bit bigger. So it's an enlarged image. Okay. So this is your fourth image formation when the object is kept between f1 and twice f1. Now moving across to the fifth image formation. Now the object is kept at focus, that is f1. Suppose it is kept here. So if you use rule 1, it goes somewhere like this. If you use rule 3, See, both the rays should be parallel. Use a scale. Both the rays should be parallel. They should not meet. They should be absolutely straight. So position of image will be at infinity. It will come down at infinity because they'll keep on proceeding like that. Nature, as always, it will be real and inverted, and size in this case highly enlarged. See, the image formation pattern is almost same, just like mirrors only. Since it is converging in nature, the pattern will remain the same. Okay, highly enlarged image is derived. Now coming down to the last of the image formations for convex lenses, object is placed between optical center and focus. So you will write position of object between F1 and O, or else you can write O and F1, same thing. Now last 5 images, if you have seen, all of them were real and inverted images. So if you use rule 1 here, so it goes somewhere like this. We use rule 3. Remember, these two rays should not be parallel. So you have to extend both the rays. Both the rays have to be extended. And somewhere both the rays will actually come together and meet. So somewhere it will meet. Okay. Now see, I've given you dotted lines because these are virtual and erect images. So position of image on the same side as the object. You will write on the same side as the object. On the same side as the object. Okay. And since it is formed on the same side, this is a virtual and erect image, and size, if you just see, it is an enlarged image. Okay, so convex lenses always form real and inverted images, except in one case, when the object is kept between optical center and focus. So these are your 6 image formations for convex lenses. Make sure that you are measuring the distance between optical center and focus and center of curvature properly. Use a scale to draw down the ray diagrams and give the rays. Without proper rays, it won't be clear. Okay, so these are your image formation for convex lenses. Thank you.